So Algebra 1, we're in 4.7. So some of you that are on the do-over algebra process may remember doing this. People that are seeing this for the first time may not, so I'll just sort of give you an honest forewarning. This is a challenging section. So whether that's life or algebra, when you're confronted with a challenge, there's two basic things you could do. One would be to curl down on the ground in a fetal position and take a beating until it ends. Or two would be try to embrace that challenge and to some degree at least battle back. And I wish I could tell you in algebra and in life, if you battle back, I'll guarantee you victory in all of your challenges, but that's just not how life works. But I will guarantee you, you do better by trying to battle it than you do just like taking a beating. So don't take the beating. And I don't want to overhype this. This isn't like life-threatening. This isn't like the hardest thing you're ever going to do in school. But this is it's a challenging lesson. There's some details here and there's some things, but we'll try to work together to make this as doable as we can for this. Do you remember last year, did you guys do these or did she skip this?
She skipped it.
She just skipped it. So I'm not a skipper. I'm thinking we just try to take it on and see how it goes. So 4.7, we're looking, these are called mixture problems. So what they're going to do, they involve percentages. So some themes that we've hit all week long. Percentages, we always want to turn them into decimals. Percentages generally look to add, subtract, multiply, or divide. Generally multiply. Sometimes because it's algebra and we're doing opposites, we might end up dividing just by accident. But percentages tend to multiply. What word do you see in sentences generally with the word percentage? Of. And of means generally to multiply. So it's a heavy duty dose of multiplication. But for these mixture problems, I think the best way to do these, the easiest way to teach somebody how to do these is to organize your information in a table. So you can see I set up 4 problems here for us to do together on the sheet we're working from. The first one I basically did the table all for you. We're down the left, I labeled start, add, and end, because we're going to start with some kind of a mixture. We're going to add something in, and we're going to end with some sort of new amount. And then across the top, I put in a total amount of stuff, heading, a percentage of acid for this question, and then an amount of acid for the final column, because we're keeping track of acid for this first one. So in other words, the top left empty square, that's our total amount of stuff we start with. So can somebody skim that sentence and tell me for that box, what's the total amount of stuff that we start with?
4.
It is 4. So start, total amount, top left corner of this table, throw a 4 in there. Let's move down a level. Can anybody spot the total amount of stuff that we're adding in?
6.
It is 6. You're not going to find it in the paragraph, but we can use our brain to deduce that the total amount that we would end with would be 10. Because we just have to do what as we work our way down that column? Add our way down. So first column, total amount, we'd have a 4, a 6, and a 10. Anybody have a question, need a run back on that? Okay, the percentages aren't bad. The starting percentage is 12. So let's not put 12%. Let's change that as we have all week into 0.12. The middle percentage of what we're adding in is a 0.24. The end, we're not going to add our way down the percentage column. Percentages don't work like that. If you start with some stuff that's 12% acid and you mix it with stuff that's 24% acid, you are not going to have 36% acid. You're going to have somewhere more than 12 but under 24. It depends on how much of each it is. If the amounts were equal, you'd be right in the middle. Since there's more of the 6, you're going to be closer to 24 than 12. But we have no real idea what that number is other than it's somewhere between 12 and 24, closer to 24. So what are we going to have to just do with that for now? Put an X, because we just don't know. Okay, so down the percentage column, there's a 0.12, a 0.24, and then an X. Question down the percent column. So that just helps us get organized. Then here's how this table works. When you work your way across these tables, multiply your way across. So we have, to start, we had a 4, we have a 0.12, we have some sort of amount of acid. We can figure that out if we take the 4 times the 0.12. What is 4 times 0.12 going to get you?
0.48.
Is 0.48. Do the same thing through the middle. Take the 6 times the 0.24, and that's going to have some acid.
1.44.
It is 1.44. And then the bottom corner is the easiest one. If you just take 10 times x, it's just going to have you put, for now,
10x.
10x. Question about how we filled that all in. So that's phase 1. Phase 2, let's create an equation. Where you're going to make the equation from, on my paper, I put a big red circle right around this last column. That's where the equation is always going to come from. The top box for your starter acid plus the middle box for your adding in acid is going to always equal the bottom box for your ending acid. That's the relationship that's always going to dictate our equation to us. So if you want to write sort of messy looking equation, we can go 0.48 plus 1.44 equals 10x. But it's always going to be from that last column. Top box plus middle box makes bottom box. 0.48 plus 1.44 equals 10x. If you'd rather write a little cleaner equation and not write that at all, I'm fine with that. Just do the available math. What do I mean? What's the available math? Just add. Do the adding. 0.48 adds 1.44. What is that going to do for you?
1.92.
1.92 would equal 10x. If you'd rather write that for the equation, I'm fine. If you want the adding version, that's fine. But we need some sort of an equation somehow from this. Adding those two boxes equals the bottom box. We just need to get something going with that. So 1.92 equals 10x is where we are. And now we're going to do our opposites, do our algebra. What are we going to do?
10 goes into 1.92.
10 divide into 1.92. And we can shortcut that one. Divide by 10, there's a shortcut for the math community. What can you do to divide by 10?
Move the decimal.
Just move the decimal. It has 1 0, so move it 1 position to the left. And I'm looking at 0.192. And my math is almost done, but I need one slight modification because the question asks us for a percentage, not a decimal
Did
answer.
you move it over to the right twice?
Move it right twice as we have all week, so it's 19.2%. Based on my conversation from about 3 minutes ago, that sort of feels right to me because it's between 12 and 24. The answer had to be somewhere between 12 and 24. And it's a little bit closer to the 24 because the 6 liters was a little bit more than the 4 liters. So we're a little close to 6's number than we are to 4's number. I think, is your test here? Did I put it on that table or not?
I don't see it.
All right, let me grab you.
I'll just grab the book now. See right now.
Anybody from that example 1 have some kind of question? Example 2. I started the chart, but I didn't quite do the full chart for you. So try to pencil in the headings on that chart. I think I might have been short one, so I'm going to run the test part off, the proof part off, and then the tab I can. That's all you wanted down here.
Yeah. Just so I know if I need to go take another sleep break.
After a brief delay, I did most of the chart. What word are we missing for this one?
Alcohol.
It'd be alcohol this time. I switched the acid to alcohol, so we're keeping track of the percentages of alcohol. So, starting amount, top left box, can you find it?
7.
No, but if we reversed it, it actually wouldn't make the problem wrong in the long run. I'd actually say the starter amount is,
13.
I'd say the 13. The 7's getting mixed in with the 13. But if we revert, like I said, if we reverse those columns, that's not going to be crucial. But I threw the 13 there. Under the 13, adding in 7. So the grand total would be 20. So we got to stack 13, 7, and 20. Question about 13, 7, 20 in a stack? Middle column, the 13's percentage.
22. Or 0.1.
Which one for the 13?
20%.
20%, which we're going to go
0.2.
0.2. So 13's next to 0.2. 7's next to 0.1. 20 would be next to
X.
X. Because we don't know what that is. We do know, though, it has to be somewhere between,
0.2 and 0.1.
yeah, somewhere between the 10 and the 20. And it's going to be closer to the 10 or closer to the 20?
20.
Closer to the 20. Why closer to 20 when we're all done?
Because there are 13 years in 20.
Yeah, there's more of the 20. So the answer is going to be more resembling the 20. Question about filling that in. Usually from the paragraph, you get like 5, 6 things filled in. Then how did we work our way across last time? How are we still going to work our way across this time? How are we going to get this last column filled in? Multiply across. So that we seem to draw a blank on that. Maybe make a note to yourself on your notes paper here for later when you're at home by yourself. Multiply across these tables. If you multiply across, that's how we're going to fill the third column in. So 13 times 0.2. 2.6 is true. 7 times 0.1. 0.7. 20 times x. 20x. So we got a stack over there, 2.6, 0.7, and 20x. Where's the equation always going to come from?
The first number plus the second.
Yeah, from where?
The last column.
That last column. This third column, we're always going to go top box plus middle box equals bottom box. If you didn't know that, write that down for later when you're at home by yourself. Top box plus middle box equals bottom box. So if you want to write 2.6 plus 0.7 equals 20x, that's fine. If you want to clean up the math a little bit, 2.6 plus 0.7 makes 2.6 plus 0.7, anybody?
3.3.
3.3. 3.3 equals 20x is even better. Then it's algebra, so at some point we've got to do some opposites, do some solving. What are we going to do here? Divide. So out of the box would go the 20 or the 3.3 out.
20 out.
20 out, 3.3 in, take a sec, divide, it'll go 3 places, it'll be point, blah, blah, blah.
.165.
0.165 is a win. Move it over twice.
16.5.
16.5%, and based on our conversation from a minute ago, we're liking that because it's between 10 and 20. It's closer to 20. 16.5, that seems pretty good. Question on that one? Okay. Third one. Throw in the headings yourself. So down the left side, we'd want to go start at end. Across the top, first one for total amount, middle one for percent of
Amount of acid.
acid, and then the last one would be amount of acid?
Yeah.
Question about the headers? Okay, what's our starter total amount, top left corner?
50
50. This is different this time a little bit in how, and what I gave you. What's the adding in amount? X. We don't know. What we're trying to figure out this time isn't a mystery percentage. What we're trying to figure out is what did we add? And we don't know. So the add in amount is X. So first problem, then we did like 4 plus 6 made 10. Then we did a 13 plus 7 made 20. So what are we going to do about this bottom box of this first column?
50 plus X.
50 plus X is correct. So we have a 50, and then below that an X, and below that a 50 plus X, because we want to add those, but that you can't exactly add them. You just put an adding problem, 50 plus X. Question about that? Okay, next to the 50, what was 50's percentage?
25.
25. So what are we going to put there?
25.
0.25. So next to 50, we're going to go 0.25. The box below that is a little bit of a trick. It usually stumps people the first time you see this, but it's not super surprising. If your local water authority, well, let's do this. What are we adding this time? We're adding what thing?
X.
No. In the real world, what is getting added? We have a bucket full of stuff that has acid in it. What are you adding into
Water.
your bucket? You are adding water. You are adding pure water. Nothing but water is going in this bucket. So if your water authority has done their job correctly on a general cup of water that came out of your faucet, how much acid is in your water? Yeah, basically zero. There is no acid in your water if your water authority has done what they're supposed to do with your water and like purified your water. There is no acid in your water. So this middle box, it didn't say what percentage of acid was in this water we're adding, because there shouldn't be any acid in the water that you're adding. It's water. Water doesn't have acid in it. If there's acid in your water, something really wrong has happened in your local community, and you should be consulting a lawyer about that. The ending percentage of acid
10%.
is 10%. So if you think about what's going on, that should make a degree of sense. We've got this bucket full of acid that's a fairly high percentage of acid that you probably don't want to put your hand in it. But if you water it down, you're going to end up with a lower percentage of acid when it's done. You've got 25% acid in your bucket. You just dump some water in there. The acid percentage is going to get lowered as you put water in there. Question about those 6. Like I said, there's usually like 5 or 6 boxes that we can fill in from the paragraph. The trickiest thing there was the 0 in the middle box. So how do we work our way across to that last column? How have we built the last column every time? And again, this time we will? Multiply straight across. So 50 times 0.25 is a 12.50 or a 12.5, however you want to express that. The middle line is by far the easiest one. It's going to be 0. Anything times 0 is 0, so we really are liking that a pretty good amount. For the last box, I just wrote a distributing problem for now. I had a 0.1 outside a set of parentheses, and in the parentheses I put 50 plus X, and I'll just worry about distributing later. If you're really wanting to distribute now, you could already do that. It doesn't make it right or wrong. It's just a matter of your own style compared to mine. But 0.1 needs to distribute into 50 plus X, whether you do that now or do that later. But then the table is complete. Question about the table? So equation again. Somebody other than Izzy who told us last time, where's the equation come from every time? That last column. And how do we work those 3 boxes to make the equation?
Just start from the bottom, like from the top to the bottom.
Yeah. And do what with them? First box,
You
add the middle box equals the bottom box. We get a nice add on this. When 12.5 adds 0, that's just 12.5. So 12.5 would equal the distributing problem. And let's go ahead and just distribute it while we're doing that. So 12.5 equals, what are you going to get if you distribute the 0.1 through the parentheses of 50 plus x?
Is it 5 plus 0.1x?
It is 5 plus 0.1x. So 12.5 equals 5 plus 0.1x. Anybody confused making the equation happen? So let's do some opposites. What would be your first opposite to do? Subtract the 5. If you subtract the 5 from the 12.5, 12.5 becomes
7.5?
7.5. 7.5 would equal 0.1x. Then to get rid of the 0.1, divide it. So 7.5 divides a 0.1. That would throw like a 0.1 outside the box if you want to do that. But for dividing decimals, the divisor outside the box has to be a whole number. So we'll slide those both over. It's really 1 out and 75 in. And anything divided by 1 makes itself. So it's just 75. Solution is 75. Question about third one. Fourth one's a little different, but it's mostly the same. Every table we're going to multiply across. Every table we're going to add down that third column to make the equation. Every table, the paragraph will give you like 5 or 6 numbers to start with. It's just they have that in common. So if you're feeling like this isn't that bad, hey, that's great. Just try to follow the steps on your own when you get there, and you may have success. And then be happy. Be happier if you get one of these right than if you got like x plus 2 equals 7 and you solved that. Like, okay, x plus 2 equals 7, you got 5, good for you. Okay, that's good. We'd rather get the answer right, but that's not quite as much of a life accomplishment as if you can like get something big right. There's a little more pride in that, I think. But take on the challenge, see what you can do. Anyway, last one. Down the left side, what's our titles? Start, add, end. Across the top, total amount, percentage sugar this time, an amount of sugar at the end. Starting total amount, did I pencil in an 80? Okay, so it should say if 80 milliliter solution. So let me fix my master sheet. You can fix your student sheet. After the word A and before the word solution, I'll pencil in there 80 milliliters. So that first box is an 80. What's the add box?
X?
That's an X. We don't know what we're adding. That's the mystery we're trying to unveil. So then the bottom box, best you can do for now?
80 plus x.
80 plus X. Percentage sugar you started with?
15.
15, so we're going to put in that box
0.15.
0.15. Skip the middle for a second, go to the bottom box. What are we creating?
0.4.
0.4, 0.40, go to the middle. And for the middle box, we're going to have to think about this for a second. We're trying to represent here the percentage of sugar. What is it that we're adding? Sugar. So if the sugar plant has done their job, what percentage of sugar is in your bag of sugar? 100%. All of your bag of sugar should be sugar. If your bag of sugar has things in it other than sugar, there's a problem, and maybe you should again consult your lawyer if your sugar is full of cockroaches or glass or equipment or bugs or whatever may be in there. I'd hate to speculate what would be in your bag of sugar other than sugar. You'd like it to be 100% sugar. Don't put the number 100 though. All percentages, including 100, we turn into decimals. So 100 would be
1.
like a 1 or a 1.00 or however you want to express that. But middle box would be 1. So basic moral of the story, if you're adding something that's a match to your headers, like on this we were adding sugar and the heading was talking about sugar, have that middle box be 100% turned into a 1. But if you're adding anything else that's not in your headers, have it be a 0. Like a minute ago, we added water to acid. We were keeping track of acid, we're adding water, that's going to be a 0. Some of these questions, they'll tell you the percentage of what you're adding, like I did on 1 or 2. But some of them, you're going to have to just use your brain to decide whether it's a 0, because it's a mismatch, or 100% because it's a true match. But after you get your 5-6 boxes filled in, let the method ride. How are we doing that last column every time? Fourth time in a row? Multiply across. So 80 times 0.15 might take us a second longer for some people than others. It is 12, 12.0, 12.00, however you want to express that. X times 1 is nice.
X.
That's just X. In my bottom corner, I'm going to make a distributing problem again. I'm going to go 0.4, waiting to distribute into 80 plus X in parentheses next to the 0.4. But if you're in a mood to just distribute that right now, go ahead, it's fine. But then we'll build the equation the same way. Take the top box, which is 12, then do what with the 12? Add the middle box, which is X, then put
12x.
after the 12 plus X equals, and then the distributing problem, which you could either distribute that now or later. Let's just go ahead and do that now. If 0.4 distributes and hits the 80 and hits the X,
Is it 0.32 plus x?
that's close and then not as close.
Oh, 0.32 plus 4x?
That's close and close.
32 plus 0.4x.
32 plus a 0.4x, there's our winner. So 0.4 distributes to 80, that's going to be a 32 plus a 0.4x. And let me go board behind me. Am I on screen if I go that high?
I'll move up a little bit.
Okay. You gonna cause an earthquake?
No.
We're settling in there. Anybody not liking how we got there, we'll rewind it. Anything
Can
trouble?
you do the distributing?
So if we go 0.4 times 80, first let's go 0.4 times x. That just attaches the 0.4 onto the x. 0.4 times 80, take 4 times 80, 4 times 8 is 32, bonus 0, but then we count. When we multiply decimals, we count. This one number counts, so I need to drop the decimal there, so there's one number worth of decimal count, but I don't need the 0.0, I can just go 32.
Okay.
Does that work? Anybody else need a rewind of creating to that point? Okay. Who's invisibly here? One. What's odd about this equation compared to everything else today, and really most of the equations this year, I'd say this year maybe 1 out of 100 equations have done this in our solving life. Why is this one sort of unique? There's 2 x's and they're located so that there's one on each side. So that's creating a little bit of problem. So what we have to do is either get rid of this one. How can we get rid of this one?
Minus 1
Subtract 1x, or get rid of this one.
plus 4x. Or is that a decimal?
That's an add and a 0.4.
Minus 4.
Subtract 0.4x. I'm going to subtract the 0.4x. Why will I choose to do that?
It's the decimal.
So you can stay positive.
So I can stay positive. This 1 is like a 1.0. So if 1 subtracts a 0.4, 12's going to wait, 32's going to wait. How much xiness will we get if the 1.0 subtracts the 0.4?
Is it 0.6?
It is 0.6. Question about that. We've done that before, it's just most of the time, we haven't had X's on both sides. We've had it, but more often we have not. Then what?
Subtract 12.
Subtract 12, if you subtract 12, we're looking at 20. Then divide, 0.6 is out, 20's in. This has to be a whole number, so slide that over, and this becomes 200. 6 into 20, 3,
18.
2,
0.
it's a 0,
3.
3 again, 18 again, 2 again, and then you have a choice of what you want to do with this remainder. We could go 1/3. You could put 2/6 and get a third when you reduce, or you could go decimal and get a 3 that repeats. That's kind of up to you. But 33 and 1/3 is it. What's that?
Is the rest of that test?
Yeah, I'd have to have Mrs. W run you one. Once you start them, you have to finish them in a sitting. You can't like start, stop the proofs.
I can come back and do it this period of time.
Okay. Yeah, once the proofs are begun, then they're just carried through. Are you leaving, or are you going to be in class?
Next period I have class.
Like for geometry, I mean.
Oh, I'll be in class.
Are you going to do the 5-7 quiz, or you want to do the proofs then?
That's
That's fine. I'll have them ready by then.
Okay.
So 33 and a third would work. 33.3 with the line on the 3 would work. Homework, we're working from the book, I believe. Let's see where we are. Yeah, there's 163 is where we're working. We're going to go from 1 to 6. So what I'm looking for is make a table, make an equation, show a little bit of work, have an answer, kind of like the whole deal. So 1 to 6, there's 6 of those. It's a pretty good match to what we were just doing. We're done learning things for a little while in terms of new lessons. So tomorrow, all we're trying to do is help you with homework, whether that's the older stuff from a couple days ago, whether that's the newer stuff we just learned today, whatever that is. Tomorrow is a homework helper sort of day. I'll give you a sheet tomorrow if you want a head start on it. I'd give it to you today. I can pull it out if you want that. But we'd have a sheet due in 2 days. We'd be taking a quiz coming up semi-soon on all these percentage lessons, but I'm thinking first we need some homework help probably tomorrow and today to happen. But yeah, now we can shut that on down.
Sorry,
No, that's my